Welcome to The Maintenance Mindset, an audio-video podcast brought to you by the Multifamily Media Network. I'm your host, Paul Rhodes, and over the more than 3 decades in the apartment industry, I've had roles that include being on-site, providing services as a vendor, creating and delivering multiple education programs, and active association work. This podcast is centered on the often overlooked role that our on-site maintenance workers play. You know, the men and women that respond in the middle of the night to the toilet call, or the after hours, it's really hot in my apartment request, or my favorite, my ring fell down the drain, get over here now. In other words, the often unsung heroes who are responsible for asset preservation and resident satisfaction. Working in multifamily maintenance provides interesting, sometimes amusing, and often fascinating stories and viewpoints. My encouragement to you is this: whatever you do it with a maintenance mindset. Hey there. This episode of The Maintenance Mindset, we're going to do the 3rd installment of water heaters. So far, we've talked about preventive maintenance that the tank requires. We've also talked about the safety measures that are in place to keep the tank from either exploding or just deteriorating over time. This episode, we're going to be looking at an electric water heater and the service that is frequently required in order to make repairs or answer service requests, more likely. If you haven't had the opportunity to hear the first 2 episodes, I encourage you to go back because we're going to pick up right where they left off. Specifically this time, we're talking about electric water heaters. Now, electric water heaters, they take in cold water and they heat it up to the maximum temperature of 128 degrees at the closest faucet. Whatever temperature we have them set at, an electric water heater is a little bit different animal than a gas water heater. Not only because of the method or the energy source that's used to elevate the temperature, but it's also a different animal because an electric water heater, it's possible to have 2 heating elements. Now, those 2 heating elements, one on the bottom and one on the top, if your electric water heater has 2 of them, they do not fire at the same time because they serve different purposes. If your electric water heater happens to only have 1 heating element, then it, of course, fires at the same time as itself because there's only 1. We're going to focus more on the 2 heating element because often the same thermostat is used to control 1 of the heating elements in a 2 heating element system as is controlled in a 1 heating element system. You see, those 2 heating elements, they do different things, and that's why they don't ever fire at the same time. The top heating element's job is to maintain the tank temperature. That means that if we have a water heater that is set to maintain the temperature of 120 degrees inside the tank, over time, the water will give up heat. Now, that heat can be lost through the T&P valve connection because that temperature and pressure relief valve that we talked about in the last episode is plumbed to what is classified as an unoccupied area. That means we may have a pipe we have a pipe that is attached to the end of the T&P valve. Now, just because there's a pipe attached, that means that some heat is going to be lost through that connection. We also will end up losing some heat through the pipes that are attached to the top of the tank, both the inlet and the outlet valve. That's heat just carried away by conduction. The rest of the heat ends up getting lost out through the insulation, and that takes time. The better the insulation, the slower the heat loss. But the reality is there will always be heat loss. That means that with your water heater set to be 120 degrees, that water temperature will regularly drop. Attached on an electric water heater, you have thermostats. Those thermostats are often referred to as snap disc limit thermostats. They get their name from the sound that they make as they switch open or closed. The way that they work is they're designed with a flat metal back that they're mounted to the side of the tank itself, meaning they are sensing the temperature of the water inside the tank as it's conducted out to the surface of the tank, the metal itself. Now, the snap disc limit, the way that thermostat works, is actually the same way as an older style thermostat that was on your wall in your apartment. We're talking about the analog thermostat that might still be in some of your places. We're not referring to the new digital programmable computers that our residents have to learn how to negotiate with. The older style, they had inside of them what is called a piece of bimetal. Now, bimetal, like the name implies, is two pieces of metal that are bonded together. And in the same way that as water, when it changes temperature, it changes density, metal does the same thing. Well, bimetal, you have two pieces of metal that are attached together that have a different expansion rate. So what that means is as the temperature changes inside that thermostat, the bimetal bends. So it's constructed so that the bending of that bimetal gives us the ability to open or close switches in an electrical circuit. That is what gives us the power to differentiate the operation from the top heating element to the bottom heating element. Those heating elements, they work just like an older style burner on an electric stove, to where when 240 volts is applied, the resistive material that's inside that burner heats up. Because the burner in a water heater is inserted into the water. When that burner heats up, it heats up the water that surrounds it. This is also why it's a very, very bad idea to turn on a water heater that has an empty tank. Your water heater heating element was designed for the water that surrounds the burner to cool the burner off. This means if you dry fire a water heater, meaning you put electricity to a water heater that has no water in it, you'll destroy the heating elements. We'll talk about how to determine if a water heater element is bad here in just a moment. The thermostat is what controls the operation of the heating element. That thermostat, by using a bimetal switch, when the temperature drops, the metal bends and it closes the circuit for the operation. This means that as a water heater temperature goes down over time, the top element, the temperature in it will cause that top element to fire first. It has a larger surface area than the bottom thermostat. This means that the top thermostat will sense more of the temperature inside the tank. And that means that on our tank that is designed or set to give us 120 degrees, if the temperature drops down to be about 116 degrees, then that water heater fires, meaning the bimetal closes the switch. You have 240 volts applied to the heating element. The heating element applies the heat to the water, and the water temperature goes up to 120 degrees. And then the bimetal opens that switch and it stops. That's why or how the top element in our water heater maintains the temperature inside the tank. Now, the bottom thermostat is connected to the bottom element, and that bottom thermostat has a different job. It's a smaller sensing surface that is attached to the snap disc or the bimetal limit switch. And what its design is to heat up cold water, meaning that over normal time, without any water being used on our water heater, the hot element will actually fire first, except when the water gets used. Remember that we have a dip tube that carries the water from the top of the tank to the bottom of the tank. And the hottest water is found at the top of the tank, and that's what leaves and goes to the faucet or the appliances. That means that when fresh water comes in, due to the fact that our hot water leaves, that fresh water is going to go down the dip tube and end up in the bottom of the tank. When it goes down to the bottom of the tank, that will cause a sudden drop in the temperature as that colder, lower heat containing water begins to fill up the bottom of the tank. Once that reaches the bottom thermostat, the bimetal in that bottom thermostat will close. And if the top thermostat happens to be firing, then the top thermostat sends power to the bottom thermostat. It gets priority. There's only 240 volts of enough amperage to run one of those heating elements at a time. We could run them both, but in order to have that much capacity, we'd have to increase the wire size, we'd have to increase the breaker in the breaker panel, and chances are we don't want to have that, especially because the majority of the time when the water's not being used, it just sits there being hot. These thermostats will vary in their design, meaning if you have a Rheem water heater and an A.O. Smith water heater, just as examples, the wiring of those thermostats will be different. It's even possible that you have to have different thermostats to make sure that they work or they function. This is why I have to go back to my standby acronym, and that is RTFI. Read the full instructions. When we get called out to go to a residence apartment for no hot water, the place where we test, where we look at it, is those thermostats, a top thermostat and a bottom thermostat. On an electric water heater, they are accessed behind doors. Those doors are often a metal dome that screws physically to the outer shell, that outer metal shell of the water heater. You remove the two screws, often held in place by 2 1/4-inch screws that you use a 1/4-inch nut driver to remove. Once you pull that cover off, there will be some insulation behind it. This insulation is critical. If it's not present, your water heater will not deliver consistent heat because it will affect the opening and closing of that bimetal switch that we mentioned earlier. When we go to service an electric water heater, the first thing to do is turn the power off. Then you remove those metal covers. And before you do anything with the equipment, evaluate the inside of those covers. Are they wet? It is possible for them to be wet through normal operation because of condensation. If you have cold air that is coming into your water heater closet, where it's found, you can develop condensation. And condensation will form on the outer surface where that cold air is hitting heated metal. It'll cause moisture to come out. If you open up the cover on your electric water heater and you find moisture inside that insulation, because the power is off, by the way, remember, we've locked out, tagged out all the electricity at the breaker, verified that you have no power there, then we can safely begin to inspect the wires and the thermostats. Because this is an area where condensation can occur, that condensation can cause very, very small shorts where the electrical connections are made on the thermostats themselves. And what that means is on the ends of the wires, quite frequently, you will get some melting of the wire insulation to occur. If that's happening, replace the wires when you replace or service the thermostats. Now, how do we test the thermostats? Well, we test the thermostats by using this. This is a multimeter. You set the multimeter to measure voltage, and you can check for 240 volts. And the way you check for 240 volts is coming into your tank, there will be two hot wires. Often one is black and the other one is white, just from a coloring standpoint. It also could be black and red. The white one should have a black stripe or electrical tape wrapped around where the electrical connections are. That helps us to differentiate white from the normal neutral wire that is in place. What you do is you take these two wires and with your meter set at voltage, safely ensure that nothing is going to touch the wires. Then you go back to the breaker and turn the power back on. If you're separated from your water heater, you may need to have another maintenance technician with you to safely power up the water heater and energize those wires without you or a resident or anybody touching them. What you're going to need to do to test voltage, you take one lead of your meter on one of the wires and the other one to ground, which as long as the grounding wire is in contact with the tank, you can use the tank. And in that case, you're looking for 120 volts between a hot wire and the tank. And on both of those hot wires, you should have or should see 120 volts on both of them individually. When you take the leads of your meter and you put your leads onto the wires themselves with it turned on, you should see 240 volts. That way you have a completed circuit. A completed circuit of two single-phase hot wires gives you 240 volts. That's the voltage test. We need to have 240 volts going into our electric water heater in order for the water heater to function. If we have that, then the water heater should be functioning. Once you've completed that test, go to the breaker, turn it off, lock out, tag out, and then commence to test the heating elements. Now, the thermostat, all a thermostat is just a switch. What that means is I've found it easiest to test the switches by testing the load. And electrically, a load is a device that does work. In the case of a water heater, the heating element does the work. The way that you do this particular test is with the power off, locked out, tagged out at the breaker. You take your screwdriver and you remove the wires from the terminals that are facing you on the back side of the heating element. Once you remove the wires, go ahead and remove both. Yeah, I know you could actually do it just by removing one wire, but go ahead and remove them both. It's easiest. Once you have those wires removed, take your meter and set it to continuity. Continuity is the test whereby you determine if there is a completed electrical connection from one point to another. The way that you tell this is by the sound. It's the one that you get the little beep. When the beep on your meter occurs, that is the quick indicator that you have an electrical connection between whatever you place one lead on and whatever you place the other lead on. For this test, it doesn't matter where you put the red one or where you put the black one. All we're going for here is that quick connection test. By the way, depending on your meter and the water heater that you're working on, it is possible that you will not get a beep and yet still you have continuity. The reason why has to do with what the tolerance is, commonly referred to as a continuity threshold for your meter. RTFI your meter to find out what that is. Once you have the two wires removed from the terminals on the back of the heating element, take your meter, place it on those terminals. A working water heater element will indicate continuity, meaning you have an electrical pathway from one terminal, which has one of your leads attached to it, through the heating element, all the way back to the other terminal, which has your other meter lead attached to it. Perform this test on both water heater elements if you have two water heater elements in your water heater. If one of them does not indicate continuity, meaning it's broken on the inside, then your repair is replace the water heater element. If your resident is complaining of not having hot water and the elements are good and the ends of the wires are good, then you replace the thermostats. Oh, by the way, always replace both thermostats. Some models have a button in the top thermostat that's similar to a GFCI. This is an overheat limit. It is not ground fault interrupter. In other words, it's not electrically analyzing anything. Instead, what it's doing is making sure that the water heater does not overheat. The most common cause for this to get triggered is if our water heater gets a lot of condensation built up, then that condensation around that top thermostat will cause the thermostat to sense greater temperature and it'll trip. If you test the heating elements and both heating elements are good, replace both the top and the bottom thermostat. Replace them as a pair. Follow the schematic for whatever water heater it is you're working on to ensure that you've got it wired correctly, and verify that the wired ends are in good shape. Remove only enough of the wire insulation to put it underneath the threaded terminal, and be sure that those threaded terminals are tight. If, when you test the water heater elements using your meter, those elements do not show continuity, in other words, it doesn't beep, or you have an infinite reading on when measuring ohms, again, refer to your instructions on your meter. If your element shows as bad, replace the water heater element. The easiest way to do this is to drain the entire water heater. However, I am aware of a maintenance technician that has two thumbs, me, that would replace them with water still in the tank. I call it a two-glug change. Again, I recommend, if you're not used to doing this, drain the water heater all the way down. If you are used to doing this, the trick is you turn off the power. Of course, it's already off. You've got electricity wires exposed, and we're performing service. And then what you do is turn the fill valve off to the water heater, open up for a quick moment, a hot water valve in the apartment, either the kitchen sink, the bathroom sink, or the bathtub. The reason you do this is to release the pressure inside the tank. Once you've released the pressure, then close the valve back. The reason we do this is because we want that water heater to be completely sealed. At that point, you can remove the element. To remove the element, there will either be 2 or 4 screws, or it's possible it threads in to where you have to use a large 6-sided socket. Once you begin removing the element, stop just before the threads reach the end. Then prepare your new element with pipe dope or Teflon tape, and then quickly pull out the old one and shove the new one in. The reason I call it a 2-glug change is because you have a sealed water heater with the pressure removed. In order for water to come out, air has to get in the tank. This is why it was critical that you close the faucet, whichever one you open to relieve the pressure. That means that in order for water to come out, air is going to try and go in the same opening. You will get, if you're fast, you will get 2 glugs of water out, and then a little bit of water draining. This is why, before beginning, have a towel. So you pull the old one out, shove the new one in really, really quick, and begin threading it down. Because air can't come out or can't get in, water can't get out. This way, you can replace the elements in a water heater without draining it. By the way, you can do the same thing with the thermostat in a gas water heater too. This is all to be done under the guise of you have to be fast. If you're not going to be fast, take the time and drain the water heater. This is the basics of working on an electric water heater. We'll be back in the future to talk about working on a gas water heater. Thank you for joining me again today. I hope you have a fantastic rest of your week, and I'll see you somewhere. Thank you for listening to this episode of The Maintenance Mindset. I hope you take away ideas that apply to your current and future career goals. Please check out Maintenance Mindset Minute to hear short-form, high-impact, applicable, maintenance-centered information. Whatever you do today, do it with a maintenance mindset. If you enjoyed this episode, please like, comment, and subscribe. Visit multifamilymedianetwork.com to learn more about our other industry podcasts, thought pieces, and sponsorship opportunities. I'll see you somewhere.